the first part of the lecture has been a generic introduction. Now we go into more specific concepts, and in particular to the one that are interested for us in this course on service engineering. The design will come later, and in particular on web services. So what are the real important concepts that we are going to use? Well, we are going to use the standard one, which is that an XML document has to be well-formed. So well-formed means that has to be a given syntax, the one that we went through before. Top element, everything must be closed, so it must be mapped to a tree. And an XML document must be well-formed. It's not just like HTML. You have to be well-formed, otherwise it will be rejected by the first run of the parser. Why it is interesting? It's interesting because now you have a framework in which you can define the general document parser, and so the parsing is done, is a piece of cake for XML well-formed document. And then there is how it goes for the parser. So usually that's the typical things that we are going to do in all our work. We are going to use XML file. We are going to eat these XML files, or we are going to make it to run it through a parser. And essentially, if there is any error, it will be just flagged out with an exception. Otherwise, it will be passed to a data structure, internal data structure in our program so that we can use it. And just to let you know, there are two essentially main type of parser, the one that are tree-based and the one that are event-based. The tree-based one is probably the most typical one that comes up to your mind if you have a file which is structures like a tree and you want to transform it to a data structure. You just map it to the data structure, and this is what it is in the document object model. It's very straightforward, it's very easy. Then internally in your data structure you have a tree. The only problem with this particular approach is that it really builds a complete tree of your document. So it really depends how big is your document, and then if it is useful or not. If your document is just relatively simple, that's the perfect thing. You have it mapped on a tree, and then you can use all the library that you want, that you are used to use it. If it is a very long file, if it is a database, then there is a performance issues that you have to consider. And for these cases, and also for the others sometimes, there is the other approach, which is event-based. It's based typically, there are also here many implementations. The most used one is Simple API for XML, is SAX. And essentially, you are using the tags as a trigger of events. So open tags, it triggers an event, and close tag, it triggers another event. And what does this in practice means is that you are reading your file sequentially, and you don't need to keep in memory the whole file, which is the other approach in which you are parsing the whole file and you transform it into a tree internally. So two approaches that both of them works very fine, they are very robust, and depends on your kind of application, of your kind of XML file, what is the best one to use. And you will see both of them in the laboratory. So essentially, again, this is an overview of what you can do with the combination of XML file and parser. And again, why I'm showing you this? I'm showing you this under the property and the concept of well-formedness. If you have a well-formed document, this is what you can do. So you can parse it and put it to a data structure, a tree, and then your program can access your tree, or you can use this XML app in which you are directly parsing your file sequentially. So essentially, that part is the tree approach, and this part is the SAX approach, the event-based. And there are a number of parsers out there, and you will see some of them in the laboratory. Now we go to the second concept, which is for our area of application a very fundamental. It's not the most important, but it's a very fundamental one. So while every XML file must be well formed, every XML file can be valid in regard to a specification of a particular schema. So what does it mean, validity? A file, an XML file, is valid if it uses not only the syntax of XML, but all the tags or all the rules that are defined for that specific language. So let's go back to our example of recipe, but we will shortly see many more examples. The file is valid if you're using only this list of tags. So you are constraining your flexibility. You are not allowing anymore that everybody just writes the tags that it's interesting, but the tags are these, and you have it somewhere. And these tags and the attributes are following some rules. The rules are the typical ordinality rule. I mean, there must be a tag. The tags can be between 1, 0, 1, or 0, n. There must be an attribute. It can be this, it can be that. So there are some generic rules. And these are specified in another document, separate from your XML file. And this document takes the name of document type definition, DTD. Or nowadays, we will see, it also goes under the name of XML schema. And this is also an interesting, let's say, philosophical point on this one. So not only the XML, in which you have completely freedom of selecting everything, but also another, you have to comply, so you don't have to comply only to the syntax, that's well-formedness, but you have to comply to other kind of rules and limitation and constraints, and these are given in a separate file, DTD or XML schema. Why this is an important concept? Because essentially what you can do now is that you can, while developing your own markup language, you can define your rules, and you can specify a number of important information, and you can use this as a validation pattern. So you can write a parser that not only checks the syntax, the generic syntax, but also checks the validation of this file and tells you if this file is valid against the particular schema. And you can, I think, clearly grasp the potentiality of this one, because it really improves the quality of the document processes. So even if you're using it as a document, you can check that the document is understandable to your particular business. Giuseppe.
Are those DTDs all continuously updated, or they are just fixed?
No, they are updated. You have to specify with the typical versioning system. So you are using SOAP 1.1, because SOAP is one of these DTDs. You are using WSDO whatever. And so it's a versioning. And every version adds some new tags and some new rules on this one. But it's an evolving thing. It's not fixed forever. The document quality is very important in exchanges in businesses, because you can define that you want your purchase order done in a proper way and must have these things. So you put down the rules, and then you can send this document, and the machine, not the person any longer, can, through a parser and through the appropriate DTD, check that the document is valid. But you can, I think, clearly see that is even more important in protocols, because if you are describing a communication protocols, this is even the rules, and the fact that the protocols has to be done in that particular way is even more important. So validation is a key advantage of using XML, and it is probably the key element that has allowed XML to really become what is now called the language of the web, because it has been used in all the three different domains that I was telling you: document processing, database, and so data base processing, and protocol processing. Now, we have talked about the generic concept, but what is this DTD? Well, DTD is another file which describes, this time in a formal way, all the things that you can have in your XML file. So, for instance, this is a version of an old version of DTD, in which you have a syntax again, in which you, for instance, say you are describing this, in this case, a document which is a book in this case, and you say that there must be a book, the element book. It could have 0 or 1 preface. It needs to have at least 1 chapter, and it can have an index, and so going, so forth, essentially. So it's a formal language, again, different from XML in this case, that allows you to put the description of the elements. The elements are the tags. All these elements are tags. And also you can put in some formal way definition of the rules that you want to apply to these tags. Now, this has been used for a while, but then people have started to say, but why should we use a different language and a different, let's say, syntax to describe how an XML files can be? XML itself is flexible enough to be able to do exactly that. And so they came with this idea of XML schema, and nowadays is more or less what you find, because it's easier, it's more, let's say, coherent to the vision and thing. So you have a particular XML language. Remember that XML is essentially a meta language that you are using to derive infinite number of languages. One of these languages is the XML schema that allows formally to do the same things that we said before. So to define, but that are also quite simple from a conceptual point of view, to define the elements, the tags, and to define the rules on these tags. And this has been done, again, only with XML. Now, I'm not going into the description of the syntax, again, of XML schema. It's just you have a number of things, the typical things that you can find in any language. So you have ways of defining data, ways of defining element type. Remember, element type is the tag. The element type is the tag. The constraints, so the rules, the relationships, and then the input and output of an option of namespaces. And this is how it is. So I think it's better just to see. Prego.
Can you please explain what is the meaning of the XSDL? I think was okay. XSDL. What's the meaning of the acronym?
Acronym? Now I have to make up. I think it's extendable schema data language. But that's I mean, I really don't know what it is. I know it is extendable schema. And I think it's coming from the previous one. DTD is data. Yeah, it's something to do with the data, but that's the point. Too many acronyms around in these fields. So let's see an example of one. Again, we don't need really to follow completely and to understand everything because it's very verbose, but the idea is this one. So let's say this is a typical example of, in business, purchase order. So you want to send a document to your customer because you want to buy something. So you want to buy something. So you are now in the phase of the designer here, because here you are defining the language that is going to describe the purchase order. So you go together with your experts of the domain, probably business people, or people who are working with in the division of selling things. And so you come up with what really is needed in your particular business. Then if you do it well, it will be probably, it's an open standard, and it will be also taken by others. And so you say essentially here that what is needed, it's some shipping information. So this is the typical, let's say, schema that you must have. You must have some shipping information, some billing information, and then the actual order. And here you are defining also some specific types like customers and what is order type. So you start, you can always start whatever you want, from the bottom or from the top. In this case, we are starting from the top. So we are the overall, let's say, abstraction. So these are the main things that you want: shipping information, billing information, and what you need to sell. And then you start to go inside, and you are defining the name of each of these items. So the customer is done by a name, which has to be at least minimum, because otherwise you are not able to get the name, and maximum can be 1. And also you are defining what kind of data you want for this particular data type. And in this case is a string. And you do this recursively for all the items that you need. For the address, for the billing date. You can define again also, you can go to the detail of defining what is the type of data that you need for your particular information. Shipping date, and then it closes down. It is continued because, as I said, XML is very verbose, it's very boring. Luckily enough, there are very nice tools that allow you to do this one in a very much, let's say, graphical way rather than writing down all these codes, because that's otherwise would be too boring. But remember, we had the customer, and we had defined the customer. Then we had the order type, the product type, and it goes again in the same way. And then I think this is the final. So we have finalized everything, because inside we had also the customer, which is this one, the order type, and that's it. So we have everything here. So you can do it. In this case, it's only for a limited number of concepts, but you do it for this concept. But the real things maybe to emphasize here, the kind of details in which you can go to define exactly the data representation that are going to be used in your XML file. Once you have this one, the analogy here is maybe one that comes better to our background, if you are a programmer, is the object-oriented analogy between the class and the object. The class is the generic information about a particular piece of code. And then from the class, you can instantiate as many objects of this like as you need in your program. So you have a class, which is a class that embed and include all the information about personal information and of a person. And then you have person A, person B, person C, etc. And that's the same here. So you have the schema of a particular document, which is 1, and then you can have the implementation of this document in this case, or protocols, and we will see that eventually you can check if it respects the initial schema. So before we have seen the schema of the purchase order, and this is how it looks like the real purchase order. You might remember that we needed a shipping information part, we need a billing information part, and we needed an order. And this is how it is done in the instance of a specific order. The address had this particular number of elements, and only this. It had also some rules about how many of these, how many names I could have in the name, which is somewhere, and how the address were going to look like, and what needed to be in the order. Not only the number, the tags, but also it was specifying exactly what were the attributes, and if the attributes needed to be string or other information, like in this case, data. And now this part is relatively simple in the sense that XML schema has taken a lot from current modern programming languages like object-oriented. In particular, the idea of inheritance. So from initially simple data types, string, integer, float, and things, you can derive more complex types, and you can do it in a hierarchical way. So you can start with an address which has only this part, and then you can adjust it to particular, let's say, specificity of like Australian address, because this is taken by an example in Australia, or Italian address, and you can extend the complex type definition. So I think I will stop here for this one, because the two messages essentially that you need in order to start to work with your XML parsing are: the XML languages is a markup language that are capable of translating everything into a tree model. Once you have it in a tree model, you can have a number of ways in which you can work with it, with the parser, and that's the well-formedness. And the second part is that you can define exactly what is needed to be in the file or not through an external file, DTD or nowadays XML schema, and you can validate every time these things. So you can validate whenever a message comes, either a message or a protocol of information. You can check if this message is compliant with your specific needs and definition. Okay? So, prego.
How is XML schema validated? Itself, I mean.
Yes.
Because it's also XML.
It's validated by another parser that it's needed.
It goes like an infinite.
It's a kind of a recursive things, right? But it's the same parsers that you can use to validate any kind of XML. You can use it to validate the XML schema in itself by a set of rules, essentially, by a given set of rules. But it's a good point. It is a point there, because because there is a recursion here. At a certain point, you have a syntax and you have a definition, and it has to follow this definition. The only nice things about the XML schema is that you don't have to switch context. In the previous DTD, there was another language which was formally accepted, essentially. And in this case, you are using, in the same time, XML language, XML syntax. But also in the other one, how can you check and validate a DTD? You do it as the validation of any programming languages. You have a compiler and you check that it's a formal language. And XML, it's a formal language.
Is the XML schema dynamically updated upon our XML document? I mean, while in the DTD you have some star node tags, and then you can validate them on your XML. Whenever you want a new specific tag for your XML, you can define it in the schema.
In the schema? Yes, you can do it. The problem is that your previous documents could be, not necessary, but could not be valid any longer. I mean, this depends what you're really adding on your XML schema. If you're just adding new tags, the previous documents are still valid. So if you're just extending, there is not a problem. as you can imagine, because you're just adding new things and so the previous one are still valid. The problem is when you are deleting things and when you are putting some constraints that previously were not there and they are now, and then they have implications also on the old documents. And I mean, there is no answer. The old documents in that case will not be valid any longer. So you have to modify your documents, your messages that you are exchanging. And this has happened in many cases for documents and also for protocols that at a certain point you're really forcing one particular new constraints typically, or you are removing because after a while you think that this one particular tag is not really very useful, you are removing it, and then you have to update your files. Okay. That's all for now then. Thank you.